Let's solve a volume problem with integrals. Let R be the region bounded by the curves y equals x, y equals 5x, y equals 10. Find the volume of the solid formed when R is rotated about the y-axis. So let's start here by first drawing our 3D object, our 3D solid, and looking at it and trying to analyze it to figure out how we can use an integral. We are rotating about the y-axis, so we're going to take this and rotate it all the way around. The way that I draw these is I start with a reflection first. So I think about if I were to fold my graph along whatever line I'm rotating around. So here it happened to be the y-axis. It could be over here somewhere, or even a horizontal line. And I imagine that my region is wet ink or wet paint. So when I fold along the y-axis, I'm going to get the reflection over here because of the wet paint. So I'm going to look at wherever my axis is here, and 2 to the right, I have my green point. So 2 to the left, I'll have a green point. And then 10 to the right here, I have my blue point. So then I'm going to go 10 to the left, have my blue point, and then I'll connect the dots. Now I'm going to imagine my rotation all the way around. So I'm going to take this blue point and I'm going to rotate it all the way around through the second blue point and back again. So I'll draw that. And I'll do the same thing with my green point. And I can start to see what this 3D object will look like. It looks like an ice cream cone. It's a cone, a solid cone that has a little smaller cone missing from the middle. My goal here is to slice this up, and I can either make horizontal slices or vertical slices. I'm going to choose the horizontal slices because when I do so, here I'm going to cut a plane out. I will have concentric circles. I'll look down on that cone and I'll see circles there. So actually this has a little bit of height associated with it. So the slice that I take out has a height associated with it. I'm going to call that height. It's going to be some distance on the y-axis, so I'm going to call it dy, and we're going to make this super, super skinny, so it's going to essentially not have any height to it. But you can imagine that I could start slices down here and keep slicing all the way up until I got to y equals 10. So we'll work on setting up our integral here. We're going to have the integral starting at y equals 0, going up to y equals 10, and I'm going to be using dy, right? I have my dy here. So I'm going to be adding up the volume of each of the slices. The volume of all of those slices together will be the total volume of the solid. So to get the volume, I'm going to need the area of the base of that slice times the height. The height's the dy, and then I'll have my area in terms of y. Everything's in terms of y here. So let's think about this slice that we have. I'm going to take this slice, we're looking at it from the side, and look at it straight down. So I'm going to be looking at it down the y-axis and looking at these 2 circles that I have here. So I need to find the area of this, and back to our earlier mathematics, we know that the area is going to be the area of the outer circle minus the area of the inner circle. And I have to remind myself that the area of a circle is pi r squared. So I'm going to need to know something about the outer radius and the inner radius. So let's start with the outer radius. The outer radius, so I'm going to go from the center of the circle out. Now remember, I'm looking straight down the y-axis, and so I can no longer see the marks on the y-axis. This is located at x equals 0, and so I need to have what this point is, x equals what. So let's go up to our blue equation here, y equals x or x equals y. So I have x equals y. I'm going to subtract from right to left, so I'm going to have the outer radius So this seems kind of like a lot of work, but sometimes we'll do something like rotate about the line x equals -1, and then we wouldn't have x equals 0 here. We would have a different value. So let's do the same thing for our inner radius. So I'm still going to start at x equals 0, and now I'm just going to the green circle, and let's see what that is going to be. Well, I need this in terms, I need to solve for x. So this is x equals y over 5, and I'll take my right minus my left. Okay, so now I'm all set. So I have this area outer circle minus area inner circle. I'm going to factor out the pi. This is going to be y squared, and this is going to be y over 5 squared. Okay, so now I have my area, and let's go ahead and sub that back into our integral. So we'll recopy that down here. Let's give ourselves some more space. And then we're all set up and ready to go. So that's a pretty straightforward integration problem. So let's just zip through that. And our answer is 320 pi.